8.4 is called graphing f of x equals a times the quantity x minus h squared plus k. So I call this vertex form. This is going to be for a parabola, but we'll get to that in a minute. First, we're going to look at even and odd functions. Okay, so we're going to get an even function when f of negative x is equivalent to f of x. Okay, and graphically, the graph is going to be symmetric about the y-axis. Okay, so let me talk about what I mean by symmetric about the y-axis. So let's say here's an xy axis. And if you have, say, a parabola, something like this, where the vertex is right on the y-axis, well, if you flip this over the y-axis, it would look the exact same. So this is symmetrical about the y-axis. Okay. All right, and then we have something called an odd function, and that's when f of negative x is going to be equivalent to negative f of x. And we'll get to these algebraic definitions and these examples in a second. But this is going to be when the graph is symmetric about the origin. Okay, which you could also say it has a rotation of 180 degrees. So let me show you an example of that. Okay. So let's see, here's an xy axis. Okay, let's say I have kind of an S curve. Maybe this is a cubic function. And if you rotated this 180 degrees, it would look the same, right? So I'll just do that. I'm going to turn my paper upside down. So remember what this looks like. You got an S curve starting at the bottom left, ending at the top right. Well, when you rotate this 180 degrees, it looks the same, right? So that would have symmetry about the origin, and so it would be an odd function, okay? There are some functions that are neither even or odd, neither one, so they don't fall into other categories, okay, and into either of these categories, okay? So we could graph these to kind of get an idea just visually if they're even or odd, but when we just have an equation, it's going to be easier to use these little tests. So what I'm going to do here, I'm going to look at, I'm going to check first if this is even. Okay, so I'm just asking myself the question, is this even? Well, let's find f of negative x. Okay, so f of negative x, that means I'd be plugging in negative x where the x is into this equation. My input is negative x. And then when I simplify this, this would be negative 5x, right? And I'm going to compare that to f of x. And f of x is just 5x. So these are not the same. So that means my answer there is no, okay? But don't assume just because it's not even that it's odd. We still have to check if it's odd or not because it could be neither one, okay? So then I'm going to do the test for odd. I'm going to check f of negative x, which I just did up here, right? It comes out to negative 5x, so I won't redo that. But then I'm going to compare that to negative f of x, okay? So f of negative x is when we're changing the input to negative x, but negative f of x, we're taking the opposite of f of x. So what I'm going to do here, I'm going to use substitution, and I'm going to substitute in what f of x is. F of x is 5x. So that means I'm taking the opposite of this whole function, and the opposite of 5x is negative 5x. And these are the same, so my answer is yes. Here it is odd, so yeah, this one, then my answer would be odd. Okay, and we're going to do these same kind of checks for these other two. So on part B, let's check if this is even. So, okay, let's check f of negative x. I do 2, and then I'm replacing the x with negative x. Okay, and then when I simplify this, I do the squaring first. So negative x times negative x is going to actually be positive x squared. Okay, and then I can see, oh, this is the same as f of x, right? F of x is also 2x squared plus 3. So my answer here is yes. And if you figure out that it's even, then you don't have to test if it's odd. If you know it's one of them, then you know it's not going to be both. So this one is even. And then we've got one more to try, okay? So this one, let's check if this is even. So Okay, let's try f of negative x. So I'll have 2 to the negative x. Okay, if I wanted to write that without a negative exponent, this would be 1 over 2 to the x. Okay, and then that's not the same as 2 to the x. So my answer there for even, that's a no. Okay, so let's check odd. So odd, so my odd one, I'm going to check f of negative x and negative f of x. F of negative x, I just did that. That comes out to 1 over 2 to the x, just like I had up there. And let's try the opposite of f of x. So I'm going to substitute in, I'm going to take the opposite of f of x. And f of x was 2 to the x. So that gives me negative 2 to the x, simplified. And these are not the same, so this is not odd either. So that means that one is neither one. Oh, sorry, I'm off screen there. I was just writing the word neither there because it failed both those tests, and so it's neither one. Okay? All right. So that brings us to the vertex form of a parabola. Okay? And this is the title of the section, really. Okay? So if you've got an equation in this format, so you're going to have just numbers in these three positions. So it might be, you know, f of x equals 3 times the quantity x minus 2 squared plus 7. So the vertex is going to be the point hk. So the x-coordinate is what's subtracted from the x, and the y-coordinate is going to be whatever is added to the end. And it might be a negative number. So it might be, if it says minus 7, then you know your y-coordinate would be negative 7. Okay. All right, so let's try this out. So I'm looking for the h and the k to find the vertex here. Well, the h, remember, it's what's subtracted from the x. So here, 3 is subtracted from the x. That's going to be the x-coordinate, okay? So one nice way to do this is to get the x-coordinate. A lot of times people get the sign wrong on the x-coordinate because they'll say, oh, negative 3, positive 2. But if you take the contents of the parentheses and set it equal to 0, and then you solve that for x, that would be my x-coordinate, and then your y-coordinate is just whatever is added or subtracted to the end. So my vertex here is 3, 2, not negative 3, 2. You can also just change the sign of this part inside the parentheses. That works. So this one's going to be negative 4, 7. Okay, but I like to do it like this because sometimes you'll encounter situations where it's like 2x plus 4, and then the 2 would actually affect the x-coordinate. That doesn't happen in this section, but it will happen at some point in the future. So it's kind of a good practice, I think, to just take the contents of the parentheses and set it equal to 0. So my vertex is negative 4, 7 here. Okay. And on this one, okay, take the contents and set it equal to 0. So the x-coordinate then is 5 when I add 5 to both sides. Now, I need to look for what's added to the end. There's nothing here, but we could write plus 0. So that means the y-coordinate is 0, okay? So the vertex is the point 5, 0. And the 3 doesn't affect the vertex at all. The 3 affects how wide or narrow the parabola is, but it doesn't affect where the vertex is, okay? Same thing with the negative 7 here. It doesn't really do anything to the vertex. It definitely does something to the parabola, but not to the vertex. Okay, so same kind of thing here. So my vertex is going to be the point negative 8, negative 9. Okay, let's try graphing some functions in vertex form. Okay, so here I've got a function in vertex form. So here's how I like to handle this. First thing I like to think, is the parabola going to open upwards or downwards? And you can figure this out without thinking about it directly. If you find some points, it'll become clear. But it's good to know right at the beginning. So this one is going to open up. And the reason why is because the a value is positive. This number up in front is positive. If that number was negative, then it would open downwards. Okay. So next I'm going to find the vertex. So I'm going to take the contents of the parentheses and set that equal to 0. And then solve for x. So x would equal 1. And then I'll take this number, and that's my y. So y equals -5. So my vertex is going to be the point 1, -5. So let's start by just plotting that point. So 1, -5 is right here. Okay, so I know it's going to open upwards from there, so I could sketch a parabola, but I want to get the width of the parabola correct. So I want to find at least 2 more points which will determine the width of this parabola. Okay, and there are a number of different ways you can do this. You could do this with the shape of the parent graph, and then this would be a vertical stretch by a factor of 2. So these points are going to be twice as high as the points on the parent graph relative to the vertex. Okay, but I'm going to do this with the y-intercept. Now, sometimes I see people look at this and say, oh, the y-intercept is -5. It's just the number at the end. Well, that works if it's in standard form. So if it's written without parentheses, the c value will be the y-intercept. But when we've got vertex form, it's a little bit more complicated. What you want to do is plug in 0 for x. Okay, because any point on the y-axis is going to have an x-coordinate of 0, because you would have gone 0 to the right or left and then up 2 or down 3 or whatever it is. Okay, so I'm going to take the original equation. I'll use a y instead of f of x, and I'm going to plug in 0 for x. So I want to figure out what y goes with an x value of 0. Okay, so then I'm going to start simplifying this. So 0 minus 1 is -1. So I did the parentheses first. I did simplified the parentheses. Okay, now I'm going to do the exponent next. So -1 squared is +1. -1 times -1, right? And then this is just going to be 2. So 2 minus 1 is -3. So that means my y-intercept is -3. Okay, so -3, that's right there. Okay. And I can use this y-intercept to get another point, because if this is my vertex down here, the axis of symmetry has to go right through the vertex, right? I know the vertex is going to be on the axis of symmetry. So what I can do then, I can take this point and reflect it over the axis of symmetry. So this is going to have a mirror image on the other side of the axis. So I can see that's 1 unit away from the axis. So I'll go 1 unit out that side. And now I've got what I need to draw in a very accurate picture of this parabola, right? And you might notice, hey, compared to the parent graph, instead of going up 1 to the right and left 1, I went up 2 to the right and left 2, because it's a vertical stretch of 2. So that's just a different way you could do it. Okay? So yeah, let's compare this to the parent graph. Well, the parent graph, I'll just draw the parent graph lightly. Well, the parent graph would have a vertex at 0, 0. Okay? But then it would go up 1 to the right 1, like something like that. Okay? And from there go up 4 to the right, left, to the right and left 2. So this light one I did here would be the parent graph. So that would be y equals x squared. Okay, so let's compare it. Well, it's translated. Since this vertex is 1, -5, we've gone right 1, down 5. So I'm going to list the transformations here. So we've translated right 1, down 5. Okay, and then also, since this is a 2, this is going to be a vertical stretch by a factor of 2. When you get a number, an a value that's more than 1, it's going to be a vertical stretch. If you have a value less than 1, it's a vertical shrink. That means that these points are stretched out vertically. They're higher up from the vertex than these ones are. Okay? All right, let's try another. So next one, first thing I'm thinking, up or down? Well, this one is going to open down, and that's because of this negative right here, okay? Because that a value is negative, all right? And then let's find the vertex. So I'm going to set x plus 2 equal to 0. So x equals -2, and then that's going to be my y. So the vertex is -2, 4. Okay, so let's plot that point. -2, 4 goes right here. I know this is going to open down, but let's find some points. So I'm going to find the y-intercept, so I'll use y instead of f of x. And then I'm going to plug in 0 for x. I'm going to find the y that goes with this. So first, inside the parentheses, that's just 2. 0 plus 2 is 2. Okay, next I would square the 2, so 2 squared is 4. Okay, now I'm going to multiply negative 1/2 times 4. So that's like taking half of 4, except it's going to come out negative because it's a negative times a positive. So half of 4 is 2. That'll come out negative 2, right, when you multiply there. And then last, the addition, that gives me 2. So the y-intercept then is 2. Okay, and hey, I know since my vertex is right here, the axis of symmetry goes through the vertex. And now I can reflect this point, so I can see that's 2 units from the axis. Let's go 2 units out the other end, so there's the mirror image of that. And now I can draw my parabola. And it does open down, just like I had predicted it would at the beginning of the problem. Okay, and then let's talk about the transformations. How is this different than the parent graph? Well, it opens down, so you could say reflection over the x-axis. Okay, and then since the vertex is negative 2, 4, that means the whole parabola is moved left 2, up 4. Those are translations. Okay, and then we also, since we've got a vertical change here, since this is 1/2, this is going to be a vertical shrink. And if you needed the factor of that, the factor is 1/2. Okay, the negative gives you the reflection, the 1/2 gives you the vertical shrink. Okay. All right, on the last page, we're going to be writing some equations based on some given info. So here's vertex form again. Okay, this says a parabola has a vertex of 3, 6, and it passes through this point. And we're going to solve for a, and then once we get a, we'll write an equation. Okay, so remember the vertex is the point hk. So I know the h and k already. So my goal here is to figure out h, k, and a. If I have those 3 numbers, then I can write the equation. Well, I already have the h and the k. Okay, so let's see what we got so far. So I could say f of x is equal to a, and then x minus h. Well, my h is 3, so x minus 3 squared plus 6, right? So I just plugged in the h and the k. All right. So now what I'm going to do is use this through point in order to solve for a. So I'm going to treat this as x and this as y, and I'm going to plug that xy pair in. I'm going to plug the y in where the f of x is, so I'm going to put 0 here. Okay, and then where the x is, I'm going to replace that with 6. And if you look at this equation now, we've only got one variable, which is the a, so we should be able to solve this for a. So I'm going to start simplifying. So let's see, this is 3 squared here. Okay, so I could say 0 equals 9a, because 3 squared is 9, plus 6. Okay, and then next thing I would do is subtract 6 from both sides, because I'm trying to isolate a, and then I'm going to divide by 9. Right here I subtracted 6 from both sides. Okay, and then a is going to equal negative 6 over 9, which would, since 3 goes into both those, that would reduce to negative 2/3. Okay, so there's my a value. Now I have everything I need. I have h and k, and I have a, so I can plug everything into the equation. I mean, I really am just putting the a value into this, so the rest of it's going to look the same, right? So my a value is negative 2/3, and then I have x minus 3 squared plus 6. Okay, let's try another like this. So remember, we're looking for a, h, and k. We've got h and k right off the bat here. Okay, so I'm thinking, okay, f of x equals a times x minus h. My h is 5, and then that's squared, plus k. So I'm going to say plus negative 2. Well, that's the same as just saying minus 2. Okay, so now I'll plug in this xy pair. So, you know, this is my hk, so you plug in the through point for the x and the y. So I put 2 there, and I'm going to put 3 in for x. Okay, and then I'm going to solve this for a. So I've got 2 equals a times negative 2 squared minus 2. And then I do the squaring next. So a times 4, I'll just write that as 4a. Okay, next I'm going to add 2 to both sides. Go up here again, so then I can say 4 is going to equal 4a. And that means a is going to equal 1. Okay, there's my a value. Now I've got everything I need. I've got the a, I've got the h, and the k. So f of x, my a is 1. So you can write in a 1 if you want. But you don't really need it, right? You don't need to write a 1 there, because I can see there's one of those. I don't need to write the number 1. If you wrote 1, it wouldn't be wrong. It would go there, but you don't need it. It's redundant. Okay, that's the end of the section, and I'll see you next time.